Here we're asked to determine all 6 trigonometric values for different angles. So first thing, make sure we know that our 6 values we're looking for are sine, cosine, tangent, cosecant, secant, and cotangent. And I've lined them up in a way that I think is helpful for me, hopefully helpful for you as well, noting that sine and cosecant pair, cosine and secant pair, tangent and cotangent pair. And we're asked to do this for 3 different angles. We're asked to use pi over 6, the opposite, negative pi over 6, going in the opposite direction from the positive x-axis, and pi over 2. At this point, you can try to draw right triangles to help yourself to get these numbers, but we want to try to work on knowing the unit circle, knowing the values that come up from these angles. So, I want to look at pi over 6 first. Pi over 6, we want to look at sine of pi over 6, cosine pi over 6, and tangent pi over 6. We'll look at these first. Sine of pi over 6, you'll notice thinking about this pi over 6 is a 30-degree angle. That means that we're looking for a 30, 60, 90 triangle. Try to remember back that the sides have lengths of 1/2 and the square root of 3 over 2. Keep in mind that the square root of 3 over 2 is larger than a half, and pi over 6 is a more horizontal angle than a vertical angle. So its x-coordinate should be larger than its y-coordinate, which means that cosine should be the larger, square root of 3 over 2, and sine should be the smaller. And tangent we can find out by dividing sine by cosine. You get 1/2 over 1 square root of 3 over 2. The 2's cancel. You get 1 over the square root of 3, which you can rationalize to the square root of 3 over 3. Now to get from sine, cosine, tangent to cosecant, secant, and cotangent, we just flip our values. Cosecant should therefore be 2. Secant should therefore be 2 over the square root of 3, which you could make 2 square root of 3 over 3, and tangent should be, cotangent should then be 3 over the square root of 3, or 3 root 3 over 3, or square root of 3. And the same idea will work for all of our other angles that we're asked to use. Once we've determined pi over 6, we can go on to negative pi over 6. Negative pi over 6 has a sine value that's very similar to what we have above. But the difference here is that we are being careful to note that negative pi over 6 is below the x-axis, which means that we'll have a negative sine value. Cosine, we're still on the right side of the y-axis, so it's positive. And tangent is again just dividing sine by cosine, and this time we end up with a negative root 3 over 3. And we can use these values to determine their reciprocal values. And when we do this, we'll see something very similar to what we have above, with only changes occurring to sine. Sine here being SIGN, or positive and negative. So cosecant will become negative 2, secant will become 2 root 3 over 3, noting again there's no change, cosine was unchanged, and cotangent should change signs because sine did. And our final angle, pi over 2, we can run through and say, well, looking at sine of pi over 2, it's at the top, which means it has a y-coordinate of 1. Cosine of pi over 2, it's at the top, which means it doesn't move left or right at all, which means it has a value of 0. And tangent of pi over 2 is sine divided by cosine, 1 over 0. Whoa, we can't do that. We divide by 0, and we got some problems. So tangent of pi over 2 is undefined. Once we know that sine of pi over 2 is 1, then we know that cosecant of pi over 2 is 1 divided by 1, or 1. Secant of pi over 2 is 1 divided by 0, again, undefined. And cotangent of pi over 2 isn't 1 over undefined. Here it's going to be helpful to think about this as being cosine divided by sine, 0 over 1, or 0. And there we have one way to go through trig values for known special angles.